Welcome to Section 1 of Computer Vision for Robotics, starting with ROS. Before we delve too heavily into advanced computer vision topics for your robot, we're going to focus on the underlying framework that we're going to be using to guide and manipulate our robot, and that's ROS, or Robot Operating System. Now, throughout this section, you're going to figure out what ROS is. We're going to walk through installing it and grab the understanding of how to navigate the ROS file system so that you can use ROS packages and ultimately write code that gives your robot an understanding of the world around it through these nodes, topics, and messages. And so you may not understand what those things are right now, but by the end of this section, you're going to have everything you need to use ROS on whatever machine that you want. Now I'm going to be using a particular robot, but these core concepts are critical for using ROS anywhere. So in this first video that we're going to get started with, what is ROS? What you're going to get is the understanding of what ROS is and why one should use it in the first place. You're also going to learn about some of the major features that make ROS a good platform for an engineer or even a hobbyist to use. Let's get started. Before I can answer the question of what ROS actually is, it really points to the question of why ROS? Why would anyone ever use ROS? Well, let's look at the current robotics landscape. There are all types of robots, from research to self-driving cars to delivery drones. There's all types of robots out there. But they all share some common needs. There's need for odometry, navigation, mapping, path planning, sensing, obstacle avoidance. The list can go on and on and on. But before ROS, let's say that you're a self-driving car engineer and ROS doesn't exist and nothing like it. So you make your prototype and you develop this communication system between your path planner and your mapping system. And you have this system ready to go, and then you decide, you know what, this prototype isn't going to cut it. I need some different pieces of hardware, and I need different sensors. So you have to refactor or completely rewrite the code that communicates between the different processes that your robot has. So the code that communicates between the path planner and the map, and between the sensors and navigation, all of that has to be refactored or completely rewritten. Now, ROS saves us some trouble, because ROS is actually a communication platform for robotic processes. So this helps you to write code that is modular. So the ROS handles the communication piece, so you can focus on what actually matters. Now, one of the core components of this robot operating system is ROS's message passing system. It allows an engineer or hobbyist to communicate between different processes or components of a robot through sending messages. So this message passing system helps ROS to have an extremely modular design. You can use as much or as little of ROS as you want. Another great thing about ROS is its amazing community support. Everyone from hobbyists to seasoned professionals use ROS all over the world. And so because of that, there are ROS packages that are already developed to do a lot of the things that engineers need to do, whether it's localization and mapping or even working like a specific robot. There are ROS packages available to you for use. So in summary, ROS is simply a communication platform for robotic processes. This helps you easily communicate between different, concepts and ideas in your robot, whether it's obstacle avoidance or path planning or sensing. ROS helps you design robot software so that these systems can communicate effectively among one another. Now, instead of talking about it in the next video, we're going to get to it. So we're actually going to install ROS and get it up and running on our machines. So I'll see you in video 2.